All right, so if P is 0.5 and Q is 0.5, then we can say that this Bernoulli distribution is symmetrical or normal. Symmetric or normal, so it means it can have this shape. Otherwise, it may vary the shape. So you know, for the shape we used to draw the histogram. We used to first collect the frequency distribution and then we draw the histogram, and based on that histogram we can tell that what is the possible shape of that distribution. In Bernoulli it's same thing, depends on the P and Q. We can talk about the shape of the distribution. So if it's half, exactly half, like in a coin toss, in a toss of a coin, it's like 1 by 2, 1 by 2, it means it's a symmetrical binomial. So that's a good example for Bernoulli distribution, where P is also half and Q is also half. Let's see how mathematically we can solve it. So I'm gonna share the screen again with you. You understood the concept of P and Q, right? Let's move ahead. Now, what does that mean? So here, the probability mass function, just in discrete, right? Just in discrete probability distribution, the probability mass function here shows us three different things. One, if x is 0, we know that the probability is 1 minus q. So if x is 1, because there can only be two possible outcomes, so that's why we are dealing with these kind of probability mass functions. Now let me explain you in a bit better way. You will also see the in example. So here, if I got number of head, let's give me a minute. So here, if I have a number of head, it's gonna be 1 minus, it's like no head. So we get x equal to 0, so it's gonna be q with the probability q. So that's the probability we're talking about. Yeah. So if it's a 1, then it's p. The probability is p, and 0 otherwise. There is no other outcome. So just to mention, to distribute, to get the distribution function, we define the probability of x in such a way. And we can say then distribution of function is 0, 1 minus p. If x is less than 0, it's 0, because that means otherwise, right? So between 0 and 1, it means no 0, right? So the probability is, because it's equal to 0, so that's why we call it q. Or q, I told you q is 1 minus p, right? So don't get confused with that. So look here, because it's less than and it's greater than and equals to 0. So because it's equals here, so we know when x is equal to 0, what is the probability? So what is the probability? Here is 1 minus p, right? And here, because we're not considering greater than 1, but equal and greater than 1. So here, because it's equal, so we know if when it's equal, the probability is p. So that's why we define the function as in such a way, 0, 1 minus p, or in this way. Do you understand? Now, if we go forward, we can have different, there are certain parameters. So what are the parameters here? What are the general parameters? Parameters are mean, mu, and variance, sigma, square. So here, the p and parameters are going to belongs to 0 and 1, right? So p belongs to 0. P can either be 0 or can be 1. If p is 1, then q is 0, right? So range is 0, 1. What will be the mean? That we say. So because it's infinite, we don't know, we didn't restrict it, so we can continue these parameters belongs to, we can only say that this parameter belongs to 0 and 1. We use it right, so by including a special condition in Bernoulli, there can be two outcomes, that's x 0 1. I already told you these two outcomes. So before going to binomial, let's go through Bernoulli. So in this way, let's say if we have a x distribution, x is 0 and 1. Okay, let me do it in this way. I think it's more convenient. So let's say if x, here, what are the outcomes? 0 and 1. What is the probability of x equal to x? The probability is, let me take you to the board. I can use the board, it's more clear. I can use the board here. I think it's better. It's clear. So what I'm saying is that we know the outcome. So x can be 0 or 1, right? So if 0 means what? 0 means failure. 1 means success. So 0 means failure means 1 minus p, probability 1 minus p, and this is p, or q and 1 minus q, right? So together we can say the sum is 1. Right? If we have a Bernoulli distribution, we can write generally in this form, x is 0, 1. What is the probability of distribution of x? Is 1 minus p, and total is 1. Right? Now we have a probability mass function, and that's, we know that our probability mass function is what? It should be 1 minus p, as I told you, if x is equal to 0. It's q or p if x equal to 1. I'm just defining in the same distribution, the same table, in such a way, 0 otherwise. And distribution function will be, f of x will be 0, 1 minus p, 1. Here, x is less than 0, because we don't consider, that's an otherwise case. If 1 minus p, if x is 0, so I can say it's equal to 0, right? Less than equal to 0. Oh, sorry. Is greater, 0 is greater than equal to x, and x is less than 1. So it's less than 1, not equal to 1. So that's why I say p. And p here is 1. And because p, it's 1, x is 1, it will be if x is greater than equal to 1. Here we know parameters are 0 and 1. Only two parameters. Range is also 0, 1. Now, it's usually if you remember, we used to construct histogram to get the shape of the distribution, as I told you before. So here we don't have a histogram when we are dealing with similar kind and specific kind of probability distribution. So parameters are playing important role in this case. The shape depends on these parameters. Right? So in this case, the shape is depending on the 0 and 1. And we know that the probability lies between 0 and 1. So probability of success is P, and simply it can be explained. So how to get mean? What is the mean in Bernoulli distribution? What is the variance in Bernoulli distribution? What is the standard error? So we know it's simple. How do we get mean? What is mean? X, P of X, and you take sum. So this will be 0, this will be the P, right? So mean, mu is always P because it's sum of X, PX, and it's P, right? And variance, for variance, how you gonna get variance? X minus mu, right? And exactly the same thing, we calculate the variance. This you understand? So here I can say that mean mu of Bernoulli distribution is P. What is the variance? Is variance of X, we know, sum of X square, expected value of X square minus expected value of X whole square, right? So you can just simply say here X minus expected value of X, and you can get into probabilities, which is that's the variance. So you can calculate it. X minus expected value of X, expected value of X is P. So it will be P into 1 square plus 1 minus P into 0 square minus P square if you open it, because expected value of X is this one. So when we solve it, it will give us P times 1 minus P. So variance of X becomes P times P minus P square, which means P times 1 minus P, which you can also write PQ. Now let's move back to the slides a little bit. Exactly, that's what I'm talking about. Uh, yeah, this we know is P. So variance of X is expected value of X square minus this. So we know that this is with the probability 1. P is with the probability 1, so P into 1 square. So because this is X is 1, so it's 0. And then this value, so this we get this one. And this we get this one. So after solve this, we can get PQ. And we know Q is 1 minus P. So these are the variance, and of course standard deviation gonna be under root PQ. So if P is given, only P is given, you can get Q. and you can get variance, and you can get mean, and you can get the parameters. Now, what is the binomial distribution? So if I go ahead, I can say that a binomial distribution is a special form of Bernoulli distribution. Only one thing is that in Bernoulli distribution, we can have infinite time when we put condition on it. When we put restriction, limit the process to finite numbers, then we call it binomials. So only difference is about n. So independent Bernoulli P, random variables x1 and x2 and up to xn. So here, that's the only difference, that we have n. In Bernoulli, it's infinite. You can have just simply one, and you can keep doing that, and everything is independent. But here you have like, not working. Yeah, now it's working. So random variables x1, x2 to xn. And by n, we limit the process. In binomial distribution, random variable means number of success is fixed number of independent Bernoulli trials. That number of arrivals in previous example, number of heads in n times. Right, so that's known as that. So the sum of these random variables x1, x2, xn has a binomial distribution. So we can say binomial random variable is a number of success in a fixed number of independent Bernoulli trials. Yeah, as I told you, number of arrivals in n times, slot times. So let's take an example. Before we just say that flip a coin and x is 0 and x is 1 if it is a head and otherwise 0. But here we say that flip a coin 10 times. Now we repeat exactly the experiment. But before going that, let me tell you the concept of combination. So n combination of r. So it means n choose r. Here in our case, n choose x, right? Or it's a combination. How to solve it? It's also known as NCR. So how many possible combination? And it can be given as n upon r and minus r, right? So what is n? How to get this? It's n times n minus 1 n minus 1 n minus 1 n minus 2 and so on, it goes to 1. And similarly r means r minus 1 and r minus 2 and r times this and so on goes to r. So let's take an example. If we have n is 5 n is 5 and r is 2. So what is NCR or NR? 5 2. Simply n is 5 upon 2 and times n minus r means 5 minus 2 means 3, and that's, so I have to calculate this one. So I can say 5 again, 2 and 3, and that's 5 times 4 times 3 times 2 times 1 divided by 2 times 1 and 3 times 2 times 1, which is 5 4 20 23 60 62 120 120 by 2 times 3 times 2 6 6 times 2 12 12, which is equal to 10. So NCR 5C2 is 10. So these are the combination. This is the formula of combination. So remember this. This formula I'm gonna rewrite again here. So NCR, also denoted by NR, is N, combination of N, R, and N minus R, right? So this is how we get the combination. So why I'm doing this? Because we're gonna use this in binomial. Because here n is 10, n is given, x is given, x is number of heads, and you just need to find out the experiment. So a worn machine tool produces 1%. So again, the p is given, x is given, n is given. So if these are given, you can find out. So these are the examples. How we do that? Well, let's go to the next slide. So flipping a coin is a binomial up to 10 times because we limit n. So n times. And worn machine tool produces 1% defective parts. X is number of defective parts in next 25 parts. So n is given. So this is also binomial. If n is not given, it's just simply Bernoulli, right? So each sample of air has 10% of chance of containing particular rare molecule. Let X the number of air samples that contains the rare molecule in next 18 samples. So here again n is given. So in all these examples, n is given, so it make it binomial distribution, not a Bernoulli distribution, right? So if there n is there, then it's everything. So if because there is n, so everything changes. Now mean will also change. That's another example. Here again n is there, next 5 bits. So how can we define and how do we calculate the distribution? We can define a random experiment consists of n Bernoulli trial, as we know. So the trials are independent. We already know about this, right? It means that every time it can have a distribution from P and Q. Each trial has in only 2 possible outcomes: success and failure. We know that because it's the same definition of the Bernoulli. The probability of success let me tell you one more thing. So here we were doing this. This was the example of Bernoulli, right? And here n is given. That's it. So if n is given, it can become binomial. So the probability of success in each trial, we know already that it's denoted by p and remains constant. The random variable x, so that's how we define binomial, this random variable. The random variable that equals the number of trials or experiments that results in a success has a binomial random variable with parameter. Now here p lies between 0 and 1. We already know that. And n is 2, 1 and 2 and so on. It depends how many times you repeat the sample. What is the sample size? The probability mass function of x is given by this. How to prove that? We're not getting it into the proof right now because it doesn't demand, our course doesn't demand for that. But if you are interested, I can tell you that it can be, if n and p is given, then you can simply calculate it by ncr and here ncx, right? P of x and q of n minus x. Simple formula. I just wrote this same formula in p and q, whereas q is equals to 1 minus p. Yeah, I told you that. So you just need to know what? You need to know 3 things: n, p, and x. That's it. If you have this, you can easily construct the binomial distribution. So here in this case, the parameters are n and p. that in Bernoulli the parameters are 0 and 1, right? So here the parameters are n and p. Remember, so range is up to n. In Bernoulli the range is only 0, 1 as well. So here by following the same, if you repeat the same Bernoulli's equation, you can get mean as np and variance as np minus into 1 minus p, because here we have np. In Bernoulli, the mean, what was the mean? It was simply p. And what was the variance? It was simply pq. But here it's so over here it's np and variance is npq. So if you have n and p given, you can easily calculate mean, variance, range, parameters. Everything is easily being calculated, and the distribution. How we do that, let's see in a little bit by solving certain examples. But first, you need to understand the concept. Now, if we have x1 to xn are independent Bernoulli random variable, then this belongs to, this is binomially distributed, not normally distributed, with mean n and p, whatever the distribution is. Yeah, we usually use this kind of distribution, right? With normal distribution is a symmetric. With the normal distribution 0 and 1. What is this normal distribution? It's a part of a continuous probability distribution. So we will talk about this in next lectures, but today we were just focusing on the discrete probability distribution. So binomial has its own distribution. We see again through the diagrams that if different p, then it can be different. So the binomial distribution is just like a Bernoulli distribution, as I told you, is a symmetric if and only if p is 1 by 2. So if p is half, the binomial distribution becomes normal distribution, right? So it becomes normal distribution. What are different shapes we can see in this example? So here, look, this is exactly p is half. So if p is half, you see that it gives us more like a normal distribution. Now here, there are two different experiments. I just put it on the same scale. So there are two different distribution. So p is 0.1. So if p is 0.1, this is the distribution. And if the p is 0.9, this is the distribution. So the higher the p is, the more skewed, more positive skewed it will be. And the lower the p is, the negative skewed will be the distribution. So there are different kind of example. I just put it together. Yeah. So if p is n is same, n is 20 and 20 and 40. So if look, it's higher. So its p is 0.5 and n is 20. So this is 20. Just consider this one, this portion, this box. If you consider this dialog box, so you see that this is normal distribution and this is more towards right, it's more towards right. So this is skewed, not skewed, but moved towards the right side, and this one is flatter because here n increases. So it doesn't matter whatever n it will be, you can easily construct the distribution by graphical representation. So here it's 20 outcomes, here it's 10 outcomes, here it's up to 40 outcomes. So the binomial distribution for selected value of np can be these different shapes. Do you understand? Now let's start doing some example. I will do one example, then I will let you to do some examples as well. Now, each sample of water has 10%. What? Has 10%? Chance. So what is this? P is given 0.10. What is Q? 0.70, right? Containing a particular organic pollutant, assume that the samples are independent. We know that in binomial it's independent from each other with regard to presence of pollutant. Find the probability that in next 18 samples, so n is 18, exactly 2 contains the pollutant. X is 2, yeah, or R is 2. So because X is the number of samples that contains the pollutant, so next, so this is given. So we already know these things. Now what is the mean? You tell me, what is the mean in binomial? So mean will be 18 times 0.10. So here mu is 18 times 0.10, which means how much? 1.8? I think so. Yeah, 1.8. So that's the mean. And variance is NPQ. So what is the variance? Is NP 1.8, 18 times 0.10 times 0.90. If you solve it, can you tell me what is the answer? 18 times 0.10 times 0.90. So it's 1.62, right? And sometimes we need to do that. So variance is 1.62, and of course you can take the square root to find out the standard error. So you see, you can get like NP, or you can get mean, you can get variance, you can get standard deviation of any distribution. Now what we have to do, we have to construct the distribution. And we know that the formula for binomial distribution is that you have NCX P power X Q power N minus X, right? So in this case, what is N? N is 18, combination of C, X is 2, P is 0.1, and its X is 2, Q is, oh, sorry. Okay, it's gonna take some time. Okay, now I'm back. So Q is 0.9, and N minus X is 18 minus 2, 16. So you can solve it and you can get P of X equal to 2. Yeah? Now let's see in a proper writing, or means typed writing. So we know X equal to this. When we solve it, we get like 153.1. You know, you can simply 0.92, 16.2854. So it means that there are 28.4% chances that the second sample, that exactly the two samples we calculate exactly are the pollutant one. Yeah, so not that high ratio. Now how can you calculate this NCR? You can calculate it also on the calculators, and you can also calculate on the internet. For example, like 18C2 value. You can just simply see. So if you open it, you can just simply see that how we calculate that. No, I wanted to know, there are different mathematical function. Just if you don't have a calculator, you are using the laptop, you can just go to this website and you can find out any formula. So 18C2 is 153. How did they do that? It's simple. That's the same formula, NCR, right? N and R. So it's 2 and 16. So if you solve, like, this is 18 times 17 times 16 times 15 and so on up till 1 divided by this is 153. So if you want to see, you can see the steps. These are the steps. See, subtract the number this, 18, 16, this, and this is the formula. 18 into 17 divided by 2, and that's how you refine it, 306, and you can simply say it if you want to see the proof as well. Now, you got this value, 28.4%. Similarly, take another example. Determine the probability that at least 4 samples contain the pollutant. Now, what do you want? Here, he's asking at least 4. So probability of X is greater than equal to 4. Now you have two options. It can be probability of X equal to 4 plus probability of X equal to 5 plus so on probability of X equal to 18. Yeah, because you have total 18. Now that's gonna be too lengthy for you. So what can you do? You can cut it short. How can one of you tell me how can we solve it in a simple way? Because otherwise you have to calculate the px probability of x equals 4 and x equals 5 and so on, x equals 18. So what's the other best possible way to calculate this one? Can you tell me what is the best way? No? One way is you can calculate the probability of x equals 5, 6, 7, 8 and so on separately, and then you can add it up. But there is another way that's simpler. You should tell me. You already know about this. What's the other way? Haotian, can you tell me? No? Do you know law of complementary or complementary probability? Probability of A. What is the complement? 1 minus probability of A, right? So what you can do, instead of going and finding the probability of 5, 6, 7, 18, what you can do, because we know the sum of probability is 1, so you can subtract 1 minus probability of x equal to, because it's greater than equals to 4, so you're not going to consider 4, so you can get probability of x equal to 0 minus probability of x equal to 1. Minus probability of x equal 1 minus probability of x equal 2 minus probability of x equals 3. Now this is more easy, this is easier. So when you calculate this one, so you have to just like putting the same value here. 2 is 0 and 1 and 2 and 3, and you can solve it and you can get the probability distribution. So you can either find out like whole. How? Like here you can have x 1, 2, 3, so on 18, and then you can have probability of x equal to x, and then put the same formula here. When x is 0, it's this one. When x is 1, it's this one, this one, this one, this one. Right? So that's how you determine the probability distribution function. Do you understand this? You're not replying me. See? That's how we do it. Or you can just solve it. Now, if we have to determine the probability that x is between 3 and 7, simple. 3 and 6, because it's less than 7, so 7 is not included. So just solve this and you will get it. Or you can just simply probability of x equal to 3 plus probability of x equal to 4 plus 5 plus 6. You can add up different probability, or you can just use this formula, which is 18 times x, 0.168. X is 3 and is sum is 6. So first you put 3, then you could put like 4, and so this is the probability of x equal to 3. This is the probability of x equals 4. This is the probability of x equal to 5. This is the probability of x equals 6. And you can get 26% chance. So that's how you define the probability. Now, let's take a few more examples and then we can end up. So you tell me what is the probability that a letter will be delivered anywhere in California in 2 days or less is 0.84. So x is what? So here P is 0.84, Q is 0.16, I mean 1 minus P, and what is N? N is 5, and what is X? You need to find out, right? But first tell me what will be the mean? Who can tell me the mean? What will be the mean? What will be the mean? Mean, variance. What will be the mean variance here? So here, what will be the mean and variance? Can you tell me the mean here? Hello, can you hear me? What will be the mu? N times 0.84. And P, we know that, right? So you can just simply put the values. Variance is NPQ, and standard deviation is under root NPQ. Yeah, that's right. That's right. So simple. Oh, why are you so slow in replying? Anyway, like that's right. 5 times 8.4. So here we have N is given, which is 5. P is given, which is 0.84. Q is given, which is 0.16. Now, what he's asking is that 5 colleges and they all are due. They all are due in 2 days. Find the probability that X arrives, that 4 arrive within 2 days. So probability of X equal to 4. Can you simply calculate it quickly? NCR, remember I tell you the formula and you will do it. P power X, Q power N minus X. So you have everything here. So what is NCX? 5 times 4, so 5, 4 times 3 times 2 times 1, 5, 4, 20, 20, 60, 62, 12, 12, it's like 120, right? So find out probability of x equal 4. Who can do it quickly? Let's compete. So 5 4s are 20, 23 60, and 62 120. So it's going to be 120 upon x is 4, so 4 3 12, 12 and 2 24, 24 and 1 24. So this one and this is 1, so 120 divided by 24, right? Because this is n minus rx, so 5 minus 4 is 1, so times p is 0.84 times x is 4, and then 0.16, and x is 1. So when you solve it, you can get it. All right, so it will be probability of x equal to 4 will be 120 by 24 and times 0.84 times 4 and 0.16 times 1, right? So you solve it and you will get probability of x equals to 4. Now let's take another example. An important part of the customer service responsibility. The responsibility of telephone company relates to the speed with which troubles in residential service can be repaired. Suppose past data indicates that likelihood is 0.70, so P is 0.70. So what is the Q? Q is 0.3. Right? So we have P and Q. Now we need to know what is N. If it's N given for the first 5 troubles reported on a given day, what is the probability that? So what is N? N is 5. Now we need everything what we want. And P and Q. So you can calculate mean, variance, and standard deviation of this, and plus you can also get the probability mass function. Through probability mass function, you can calculate the probability distribution. So one A part is like we have to find probability x equal to 5. Simple. Solve, put 5 CR yeah, just give me 1 second and then I will let you go. So 5 CR x is 5 and P 5 Q 5 minus 5 0. So that's how you calculate. And in another fewer than 2, yeah, will be repaired. So that's how we calculate the probability.